So let's solve to sample problem number 3. Light gauge cold form steel channels used as purlins are simply supported on roof trusses 6 meter apart. So yung mga spacing ng trusses natin is equal to 6 meter. So usually naman ginagamit talaga as purlin is yung mga sig section natin. So we have a given, yung roof slope natin is 1 vertical is to 4 horizontal. So in this example, eto yan, 1 vertical is to 4 horizontal. And we have a value of dead load, which is nakalagay dito, purlin weight included. So meaning to say, yung weight ng beam natin or weight pala ng purlin natin is kasama na siya dito sa 720 Pascal. And we have a given live load which is equal to 1,000 Pascal. Yung wind pressure natin which is equal to 1,440 Pascal. Siyempre, meron tayong mga wind pressure coefficient para mag-act perpendicularly dito sa purlin yung wind natin. So, kaya meron tayong wind pressure coefficient. Kasi yung purpose talaga ng wind natin is laging normal yan sa mga purlins natin. So, let's say meron tayong bubong. So, siyempre, yung wind natin naka-apply dyan perpendicularly sa bubong natin. So, ito yung roof natin. So, since yung wind natin is kalat-kalat siya, kaya nangyayari is nagkakaroon tayo ng wind pressure coefficient. Kasi let's say meron tayong dito. Sabihin natin, yan yung frame ng bubong na, ito yung column natin, tapos ito yung bubong. So usually, ito yung wind pressure natin. So meron tayong wind pressure. So para ma-apply yan dito sa bubong natin, nagkakaroon tayo ng wind coefficient para mag-perpendicular yan. So kaya meron tayong coefficient. Kapag in-applyan natin ng coefficient yung wind pressure natin, mag-a-act na siya perpendicularly dito sa bubong natin. So next naman, we have the properties ng purlins natin. So kung mapapansin niyo dito sa given natin, nakalagay dito, assume all loads pass through the centroid. So meaning to say, lahat ng loadings natin is acting siya sa centroid ng purlins natin. So ito yung purlin natin na C-section. So lahat ng loadings natin acting siya dito. So meaning to say, hindi na tayo magkakaroon dito para makuha natin yung actual bending stress. Hindi na natin kakalahtiin yung value ng S sub y natin. So, yung buong S sub y na yung mapapakinabangan natin sa pagkuha ng actual bending stress. So, let's solve the safe spacing due to the dead load and the live load. So, gagamitin natin yung dead load at saka live load natin. So, kapag kumukuha tayo ng spacing, lagi natin ginagamit yung interaction formula. So, that will become yung actual all over yung allowable natin plus yung actual natin along sa tangential all over yung allowable natin along sa tangential. So, kung mapapansin ninyo, given na etong mga allowable bending stresses natin, hahanapin na lang natin etong mga actual bending stresses. So, equate lang natin siya sa 1. So, kunin muna natin etong nasa normal natin. Kunin natin yung FBX muna natin. Yung actual bending stress natin dito sa normal. So, dito, kung mapapansin ninyo, that is equal to MX all over SX. So, since sinabi dito sa problem na dead load plus live load, so kunin natin yung value niyan. So, we have 1,000, yung live load natin plus yung dead load na 720. So, we have a value of dead load plus live load which is equal to 1,720 Pascal. Wherein yung Pascal natin, naka-Newton per meter squared dyan. So, kailangan nating gawing Newton meter yan. So, para maging Newton per meter yan, para maging uniform load, kailangan nating i-multiply etong spacing natin. Since gusto nating makita dito sa purlin natin yung uniform load, that's why dito natin siya i-multiply. Kasi at every meter dito sa spacing natin, makikita natin yung uniformly distributed load caused by the dead load and the live load. So, kunin natin yung value ng W natin. So, that will become 1,720 multiplied by S. So, you will have 1,720 S Newton per meter. So, yung W natin in this problem is acting siya dito sa gitna ng C-section natin. Kasi sinabi dito, all loads pass through the centroid. So, para makuha natin, mangyayari kasi, since nakuha na natin yung value ng total loads natin, etong total load natin na yan, that will act, since i-consider natin is yung axis ng C-section natin. So, magiging component yan, magkakaroon tayo ng WX at saka WY. So, para makuha natin yung dalawang yan, so, kailangan muna natin makuha yung value ng theta. Wherein theta is equal to tangent theta is equals to opposite, which is equal to 1 all over 4. So, the value of your theta is now equal to 14.04 degrees. So, kunin na natin yung value ng WX natin. So, WX is now equal to 1,720 tapos yung small s natin. So, since yung theta natin, it is located dito. So, that will become, since normal yan, cosine of theta, which is equal to 14.04. So, you have a value of WX. So, we have 1,668.62 S Newton per meter. Susunod naman is yung tangential, yung W sub Y natin, that is 1,720 S sine 14.04. So, we have 417.27 S Newton per meter. So, meron na tayong value ng WX natin. Makukuha na natin yung value ng FBX natin. So, FBX is equal to yung MX natin. Since it is simply supported, no? So, mangyayari is WL squared all over 8. Yung WX natin, eto yan, 1668. 1668.62 S. So, yung L niya, which is equal to 6 squared all over 8. So, multiply natin yan by 1 times 10 raised to 3. Kasi nga, yung value ng W natin dito is naka-Newton na. Yung i-convert lang naman natin is yung value ng meter natin. Gagawin natin siyang millimeter. Kaya, nag-multiply lang tayo dito ng 1 times 10 raised to 3. all over yung Sx natin, which is equal to 6.19 times 10 raised to 4 cubic millimeter. So, susunod na kukunin naman natin is yung value ng FBY natin. So, yung MY natin, that will become yung WY natin, 417.27 S, 6 squared all over 8, multiply natin by 1 times 10 raised to 3, all over the value of your SY, which is equal to 1.38 times 10 raised to 4. So, since dito sa ano natin, sinabi dito na all loads pass through the centroid, so meaning to say, no, hindi natin kakalahatiin yung value ng S sub Y natin. So, yung value pala natin dito sa FBX is equal siya sa 121.31 S megapascal. That is megapascal. Yung sa susunod naman sa FBY natin, that is 136.07 S megapascal. So, yung unit nila is in megapascal. So, gamitin natin yung interaction formula. So, yung actual over allowable, yung actual natin is equals to 121.31 S all over yung allowable na 207 plus yung actual natin na 136.07 S all over the allowable na 207. Equate to 1. So, we have a value of S is equals to 0.80 meter or 800 mm. So, this will now become our answer for letter A. Next, we will solve for the value of the spacing of purlins. Due to the dead load plus live load plus wind load at leeward side. So, meron tayong special case dito. For dead load plus live load plus wind load, a 1/3 increase in allowable stresses is allowed. So, etong condition na to sa NFCP, i-apply natin yan mamaya sa mga allowable stresses natin. So, siyempre, no, meron tayong tinatawag na coefficient, yung ang na-explain ko kanina. Etong mga coefficients na to, ginagawa niya is automatically, perpendicular niya sa bubong yung wind natin. So, kapag sinabi nating leeward, so let's say, no, meron tayong ditong frame. Ayan, yan yung frame natin. So, yung mga ano natin kasi dito, let's say, eto yan. Yung mga wind natin, kapag yung wind pressure natin, kapag minultiply natin ng coefficient, mag-a-act yan perpendicularly. Dito sa frame natin. So, in this example, hindi lang naman sa ganyang posisyon, nagkakaroon tayo ng ano. So, meron tayong dito minsan naman is, pag ganyan din naman yung wind natin. So, papasok siya, tapos lalabas. So, meron din naman tayo dito. Tapos, meron din tayo dito. Ayan. So, usually, ganyan yan, yung wind natin. So, dito magsi-circulate siya, tapos lalabas, dito din lalabas. So, yung wind pressure natin, magiging perpendicular lang siya dito sa frame natin kung nagmumultiply tayo ng wind pressure coefficient. So, in this example, meron tayong tinatawag na leeward at saka meron tayong tinatawag na windward at saka leeward. Kapag sinabing leeward, ito yung paalis yung, ito yung leeward. So, leeward, paalis yung wind natin, yung wind pressure. So, kapag naman, windward naman, so, papunta siya dito sa roof natin or sa purlin natin. So, ito naman yung windward. So, meaning to say, kung mapapansin ninyo, no, yung wind pressure natin, always acting siya ng normal dito sa roof natin. Or in other words, laging perpendicular etong wind load natin, yung mga wind loads natin sa mga bubong natin. So, meaning to say, kung laging perpendicular yan, so perpendicular din siya dito sa axis ng C-section natin. Meaning to say, acting lang siya dito sa normal. So, wala siya dito sa tangential. So, mag-a-act lang yung wind load natin kasama dito sa normal load natin. So, recalling, no, yung nung kanina, sa dead load plus live load, yung value ng Wx natin is equal to 1668.62 Newton per meter. Yung Wy naman natin is equal siya sa 417.27 Newton per meter. Since along normal lang yung maapektuhan dito sa wind pressure natin, so kapag kinonsider natin yung dead load plus live load plus wind load, so maapektuhan lang dyan is yung Wx natin. So yung Wx natin, sabihin natin that is Wx sub 1. So that will become, so since leeward to, so palabas, so eto lagi siyang acting perpendicular or normal dito sa mga purlins natin. So since palabas yan, magiging minus yan. So we have yung dito sa dead load natin na 1,668.62 S. Since leeward dyan, so that will become minus. So yung wind pressure natin na 1,440 Pascal. So naka-Newton pa yan, Newton per meter squared. So multiply natin yan by S. Multiply natin yan by S o yung spacing para maging Newton per meter multiplied by the coefficient natin sa leeward, which is equal to 0.16. So the value of your Wx sub 1 is now equal to 804.62 S Newton per meter. Ngayon, yung value ng Wy natin, since hindi naman siya naapektuhan ng wind load, so same lang. So parehas lang na 417.27 S Newton per meter. So kunin na natin yung value ng FB natin, x sub 1, sabihin natin, kasi kinonsider natin is dead load plus live load plus wind load. So kunin natin yung actual. So we have yung mx natin. So gamitin natin yung W. So that will be WL squared over 8 S. Yung L natin, ito yung spacing ng truss natin na 6 squared all over 8 multiplied by, since naka-Newton na yung W natin, ito na lang M, kaya 1 times 10 raised to 3 all over the value of your Sx, which is equal to 6.19 times 10 raised to 4. So you will have a value of 58.49 S megapascal. Next, so since meron na tayong value ng Fp x sub 1 natin, So, yung kanina lang, di ba, magbabago lang naman is yung FBX sub 1 natin. Wherein yung FBY natin, yung actual natin, same lang siya dito sa dead plus live load natin. Since hindi naman siya naapektuhan ng wind pressure natin. So, same lang yan, which is equal to 136.07 S. So, gamitin lang natin. So, meron tayong dito yung actual natin. So, yung value ng actual all over yung allowable plus yung sa actual along the tangential all over yung allowable natin dito sa tangential equals to 1. Since kinonsider natin dito sa problem na dead load plus live load plus wind load, sinabi dito for dead load plus live load plus wind load, a 1/3 increase in allowable stresses is allowed. So, mag-a-add daw tayo ng 1/3. So, mag-a-add tayo ng 1/3 increase. So, paano yon? So, kung meron tayong FBX dito, let's say, sa mga allowable to allowable stresses. So, meaning to say, applicable lang yan dito sa FBX at saka FBY. So, let's say, meron tayong FBX. So, add lang tayo ng 1/3 niyan. So, kung pag-a-add mo yan, magkakaroon ka ng 4/3 FBX. So, in this problem, lalagyan lang natin yan ng 4/3. 4/3. Or kung titingnan ninyo, no, since common factor to, magiging common factor siya. So, magkakaroon tayo dito ng 1. So, that will become 1/4/3 or 3/4. So, mangyayari sa formula natin, that will become 3/4 or 0.75. Imumultiply mo siya sa value ng mga nakuha natin. So, ano yung value ng FBX sub 1 natin? That is 58.49 S. All over yung FBX natin, which is equal to 207, plus FBY, which is equal to 136.07 S, all over the value of your FBY na 207. So, equate natin sa 1, makukuha na natin yung value ng S natin, which is equal to 1.4 meter. So, for next naman is the safe spacing due to the dead load plus live load plus windward at windward side naman. So, kapag sinabi natin windward, no? So, going siya dito sa purlins natin. So, mag-a-add siya. Since acting lang to perpendicularly or normal sa purlin natin, so, etong normal section lang yung maapektuhan. Etong tangential section natin, hindi yan maapektuhan. That's why, so, kuha tayo ng bagong value ng WX2 natin due to the windward naman. So, consider natin right now is dead load plus live load plus windward. Wind load. So, yung WX natin, considering dead load plus live load, is only 1668.62 S. Ngayon, mag-add tayo dito kasi windward plus leeward minus, no? Windward plus leeward minus. So, dito plus siya. So, yung wind pressure natin na 1,440. So, naka-Newton per meter square dyan. I-multiply natin by spacing para maging Newton meter. I-multiply natin ng coefficient niya na 0.18 para mag-act siya perpendicularly or normal to the purling. So, we have a value of WX sub 2 which is equal to 1,927.82 S. Next, para makuha natin yung FBX2, So, WL squared over 8. So, yung W natin, 1927.82 S. Since naka-Newton na yan, tapos yung length natin is 6 squared all over 8. Yung i-multiply natin dito is 1 times 10 raised to 3. Since naka-Newton meter na siya, all over yung SX natin, which is equal to 6.19 times 10 raised to 4. So the value of your FBX sub 2 is equal to 140.15 S megapascal. So, since hindi naman naapektuhan yung FBY natin, re-write lang natin siya. So, meron tayong 136.07 S. So, gagamitin lang since kinonsider natin is dead load plus live load plus wind load. So, maglalagay tayo lang 0.75 sa dulo multiplied by yung FBX sub 2 all over yung allowable plus yung FB sa Y all over yung allowable, equate natin sa 1. So, we have 0.75. Yung actual natin is equal to 140.15 S all over yung allowable, which is equal to 207 plus yung actual natin, which is equal to 136.07 S all over 207 is equals to 1. So we have a value of spacing which is equal to 1.0 meter. So yung mga spacing natin, laging ano yan So that will become yung discussion natin